Okay, so today we're going to learn how to make printed circuit board designs using the Easy EDA software. That's going to help us turn these kind of big, clunky breadboarded circuits like we built in the Arduino lab and turn them into really nice circuit boards that we can solder components into. So to get started, what we're going to do is we're going to go to the easyeda.com website. And if this is your very first time using the software, you'll click on the register link right here, and you can give them a username, your email, a password for your job function. You can click that you're a student, verify that you're not a robot, and create an account. So I already have an account, so I'm going to sign in, and I am not a robot, and I will log in. There we go. Okay, so once you're logged in, one of the very first things that I'm going to have you do is you're going to join the Intro to Prototyping Development group. And in order to do this, there's a link down in the description below that you can click on or copy and paste the whole link. And so if you go to that, it'll have a key here that's going to allow you to join our group, and that's going to give you access to all of the parts that we're going to be using for our project today. And so I'm going to click on that or copy and paste it in, hit enter, and it's going to say successfully accepted the invitation. And that's great. So we'll click detail, and that's going to kick us back to this page, and that means that hopefully we're a part of the group now. So to get started, we're not going to click download. We're actually going to use the online tool, which is a lot easier to use. And so we're going to click on this Easy EDA Designer, and that's going to take us to this page here where we can get started with a new project. And so, like I said, this is the part that we're going to be creating. And so we're going to kind of design first a schematic that's going to kind of represent all of these parts symbolically. And then we're going to work on creating an actual circuit board that could be manufactured. So let's get started. We're going to go to File and click over on New Project. And we need to change the owner. And what we want to do is we want to make that the Intro to Prototyping group. So once we have Intro to Prototyping selected, we're going to title our work, and this being our very first PCB, of course, we're going to call it Hello World, but I'm going to say Hello World dash, and I'm going to give it my full name, and you should give it your full name too so we can tell the difference between your project and my project. At that point, we're going to hit Save, and it's going to open up this, this window here, and this is where we're going to be able to kind of build our circuit symbolically. This is called an electronic schematic, and this is the type of thing where you could send this to any technologist or any engineer in the world, and they'd be able to understand what your circuit was about. We're going to change a few things first, though. Down here in title, we're going to change the title of this to Hello World. Company, I'm going to call my company Hackberry Lab, but you can make up a name for your company if you want. And drawn by, it's got my screen name there, but I'm going to put my full name in there. So that everyone knows that I was the one who drew this. Okay, and then you can kind of go to File and Save, or you can hit Control S or Command S, whichever is easiest for you, just to save some time. All right, at this point then we need to go start gathering some components. So let's look at the components that we need. Well, according to this circuit, we need an Arduino, we need a little push button, we need a 10K resistor, that's this orange, black, brown one, a 330 ohm resistor, and a red LED. So let's go shopping for all those components. The way that we can do that is we can come up to the Place menu, and you see there's an option here called Symbol, and that's going to allow us to find symbols that represent each of our electronic components. You can also hit Shift F as a quick key, but let's go ahead and start searching. Now in here, there's a lot of different components that you could go searching for. So LCSC is a part supplier, and they literally just have millions of components that you could place. But we don't really need millions of components, we just need a few basic, simple ones. And so we're going to click on Workspace here, and in a list here, there should be something called Intro to Prototyping. So, let me try that again. So, click on Workspace. There we go. And we're going to click on All under Intro to Prototyping. And here we'll see there's only a couple parts to choose from because we've kind of narrowed down that huge list down to just a few. So we can go through and say, oh look, there's an Arduino Nano here. And so I'm going to move this window here and I'm going to click on the Arduino Nano. And we can see there's a little picture of it. And I'm going to come and over my workspace, I'm going to click my mouse once. and it's going to drop an Arduino Nano right there. We only want to click once because we only need one. But let's look at some of the other things that we need. We do need a push button. We had talked about that. So I'm going to come and drop one over there. We need a 10K resistor to go with that push button. We also need a red LED and a 330 ohm resistor. Okay, and at this point we can kind of click cancel, and I still have kind of a leftover resistor here. I can just hit escape and that will make that go away. So let's kind of just double check what we've got. We've got an Arduino Nano, a push button, 10K resistor, red LED, and 330 ohm resistor. Arduino, push button, 10K, red LED, 330 ohm. And that's pretty good. What we don't have here are these little breadboards or these wires, but we don't really need those just yet. I'll show you how those are represented in the software next. One of the very first things that I want to do, however, is kind of organize my parts a little bit better. So I'm going to kind of put my Arduino Nano over here. I'm going to bring my push button here, and I know my 10K is going to be kind of close to my push button. Those are going to get hooked together because I can see they're really close together on this board here. And the same is true for our LED and our 330 ohm resistor. I can see that they're going to be relatively close to each other as well. And so what I'm going to do now is actually work through making these wired connections in my schematic. So let's start with our push button first. Okay, so I notice here that I've got a wire going from 5 volts over to one of the corners of my push button. Well, let's take a look and see if I can do something similar here. Okay, so I'm going to go find the 5 volts. Well, there's the 5 volt button right there. And I'm going to pick one of the corners of the push button and I want to connect them together. The way that I can do that is with a wiring tool. And so if I come and click this wire right here, I can come over here and you'll notice that when you get really close to that pin, this little 5 volt pin, that a black dot pops up. And that means that it'll start a connection. You always want to look for that black dot. And so if I click with my mouse, suddenly I can drag a wire over here. Now I want to kind of steer clear to make sure I don't accidentally cross over any other pins. And so I'm going to line this up with that one. I'm going to click to add a little bend. And I'm going to come over and again looking for that black dot. I've made a connection. So I've made 5 volts over to 1. Okay, so that's pretty good. So let's go check our schematic here and see what other connections I need to make. Well, I've noticed that over here, my button also on the opposite corner seems like there's a yellow wire that comes out and it traces up and over and it goes over to the D3 pin on the Arduino Nano. Well, let's see if we can recreate that. So I'm going to come to the opposite corner here, okay, and I'm going to kind of snake my way around, and again you can do these just by clicking over here to the D3 pin of the Arduino Nano. And so now I've got a nice connection over there. So far so good. I've also noticed that that same corner is kind of hooked in to one side of the resistor. So let's go see if we can kind of create that as well. Well, this side is hooked into a side of the resistor. And actually the resistors can go either way. They don't have a plus or a minus. And so we can just connect this push button right to the end of that resistor and we're good to go. Okay. Now the other side of this resistor, it seems to be hooked up to this wire here, and that wire, if we trace it back, goes to ground. So let's see if we can connect that other end of the resistor up to ground. So looks like I've got a ground here and a ground here. Either one is okay. I'm going to come over to this ground here, and I'm going to be kind of careful. Again, it's okay that in the schematic view that these wires sort of cross over. These aren't connected. But I do want to make sure that I get over to the ground and that things look pretty clear. So it seems like we might be able to trace this pathway pretty well. So now we've got our push button all hooked up. Next thing, let's look at our LED. Well, if we look at here, it looks like one side of our LED, the long positive side of our LED, traces across this green wire and ends up over at D2. So let's look over here. Okay, so now, well, which side is the positive side? Well, one of the things I like to look at is with this LED symbol, there's this line right here, and I like to think of that line as the big negative. So that would go to ground, so that's not what we want. So it means that this side must be positive. And so what I'm going to do is I'm going to click here, and we're going over to D2. I'm going to click over and around and come hook up to D2. So I've made that wired connection right there. Okay. Looks like the negative side of this is hooked up to a resistor, and then the other side of the resistor comes down and goes all the way over to ground again. So let's see if we can do that. So this side goes to the resistor, and then this side goes over to ground. Okay, and again, I get my choice of grounds. I'm going to come up and I'm going to go to this other ground connection, but either one will really do. And at this point, it looks like we've got a completed circuit. All of our components are all hooked up, and that's good. To get out of this wire mode, again, I can just hit escape to make it go away. And let's go ahead and save our progress right here. So I'm going to go to File and Save, and this is our completed electronic circuit diagram. Again, anybody could follow this and kind of see what parts you needed to use and how they could be hooked up. It's very similar to this kind of breadboarded view, but just a little bit more universal. But this isn't quite a PCB, a printed circuit board. We need to kind of design that. Now in here, it was okay for us to be able to kind of cross these wires because these are just symbolic. But when we get over to our printed circuit board, things are actually a little bit different. Those are going to be physical pieces of copper that are laid on a board, and they can't cross over. So things are going to get a little bit more difficult for our next stage. So let's go ahead and go on over to that. What we're going to do is we're going to come up over to Design, and we want to convert this to a PCB. So we'll click this. It might say that there are some unfinished nets. Do you want to check? And we know unfinished nets means there's some kind of empty things we didn't hook up, and that's okay. Well, that was intentional. So let's keep going. Okay, now at this point it says, great, let's create a new PCB. And we can leave these values default. They should be okay. And so we can go ahead and hit Apply. Okay, if we kind of zoom out, one of the very first things that we're going to do is we're going to come over here to units, and we're going to make sure that these are in millimeters. In terms of making things a little bit easier to see, we're going to change our grid size. I like to have a 5mm grid size, and for my snap size, I'm going to set snap size to 1mm. And that just means as we kind of drag things around, a little bit easier to see where they're going. So here are our components all kind of floating up in here. And you might notice that these actually look like real components now. And there's a big kind of purplish pink box right here that kind of shows us, I'm going to minimize that for now, shows us the outside edges of our printed circuit board. And so our job is to get all of these components organized neatly in here. And you'll notice that these components are hooked together with these little blue kind of, stretchy elastic lines. What these are doing is showing us kind of guides as to what components need to get hooked up with each other, but these aren't actual solid connections yet. Our job is going to be, once we've kind of placed our components, to actually go and create these solid copper wires that will be embedded in the board that will make all of these electrical connections for us. And so one of the very first things I'm going to do is I'm going to move my little Arduino to this side of the board. That seems to be a pretty good place for it. And I'm going to move down all of these components, and again, there's kind of some assumptions that we can make. So here's my little switch, and I can assume that my switch is going to go near this resistor, so I'm going to place them relatively close to each other. And I'm going to bring my LED down and my other resistor down, and I'm going to place them right about here. Okay. And so one of the things I want to be on the lookout for is kind of places where it seems like maybe the wires are getting tangled up or twisted. These don't look too bad, but if you do get a component that seems like it's in a weird orientation, you can select on it and hit the R key, and the R key will kind of rotate it around until the wires don't look so twisted anymore. So again, here, I'm just going to kind of explore around a little bit and see if there's any kind of rotations here that make things a little bit nicer for us. So it doesn't have to be perfect, but it should just try to be close. Okay. Now at this point then, let's go ahead and see if we can start making some connections here that will allow us to complete this circuit. One thing that we want to double check is that over here in routing conflict that it is set to block. And what this will do is it actually will help us physically prevent us from making a mistake. So I'm going to get started, and I'm going to start here up with my switch. Now again, like before, I need to kind of make a physical connection here. So I'm going to come over to my track tool, and I'm going to start here, and I'm going to want to follow this blue line across. So I'm going to click here, and I'm going to add in a little bend, and you can see that blue line suddenly turned into a red wire. This represents a real copper wire that's going to be embedded in the board. Okay, well now let's look to see, I'm going to make this other connection over here from our switch over to our resistor, and now that one's all hooked up, which is pretty good. Now we've got a problem here. If I come over to this, and I come over and I try to follow that blue line, you can see how it's wanting to get to the ground, but it won't let me actually connect to it. And what's happening here is, if I zoom in here, I'm trying to kind of cross over this previously existing line, but it's not going to let me do that. There's a physical barrier now there because there's already a wire there. So we could try to kind of snake our way through these little spots, but it turns out that on circuit boards, there's a top layer that we can put wires, and there's a bottom layer that we can put wires too. And so if I run into this issue of needing to kind of get from one place to the other and it just won't let me through, I can click on this little blue layer, and you can change this pencil to it. We can click on our wire tool, and now, since I'm working on the bottom layer of the board, there's no problem there with kind of crossing over that. And so that's going to help you make connections where they may otherwise be kind of infeasible. Okay, well, let's look at this other side of the resistor. It needs to come all the way over here to D3. Okay, well, I could choose what side of the board. I'm going to work on the top layer, and I'm going to click on that, and I'm going to work my way around the board, and you can click along the way. You'll notice that I am trying to avoid making 90-degree angles. In circuit design, 90-degree angles are actually kind of bad, and so I am trying to kind of keep 45-degree angles as much as I can. But you can see now that that's hooked up all the way over there, and it doesn't run into anything along the way. So this actually kind of becomes a game for kind of how can you organize your components, or how can you route your wires in the way that's most efficient but also avoids collisions. So let's kind of come down over here. We've got our resistor and our LED to hook up. Okay, well, looks like my LED wants to come over here to D2, so that's okay. So I'm going to bring it down, and again, it kind of can't make my way through these holes here. But I'm just going to come up and make a connection there. Okay, looks like I have a connection here between my LED and my resistor. And again, I've got an issue here. If I try to get over here, I'm going to run into these reds. But again, no big problem. I can jump down to the bottom layer, and I can work my way around and come up and hook up to ground. Again, just to get out of this, you just hit escape. Okay. Now at this point, it looks like I'm in pretty good shape here. It looks like I don't have any of those little thin blue, they're called rat's nest lines. Everything is a solid wire now. And so I'm going to go ahead and click Save. And we want to kind of double check a few things to make sure that we have, in fact, got everything connected. So if I come over here and click on Design Manager, if I click on Nets and I click this little refresh button, okay, I should see that I've got 33 out of 33 connections. If there's any X's there, it may mean that you've kind of missed a connection or you've made a small mistake. I'm going to close that up. Next thing is we're going to do what's called the Design Rules Check Errors. And so we're going to hit that refresh, and it's going to check, and looks like it didn't find any errors. So that's great. And so at this point then, we just have one final thing that we want to do, and that's that we want to look at our circuit in 3D. And so there's a 3D button right here, and we're going to click on that. And it's actually going to render our circuit board in 3 dimensions, so we can kind of see those little traces that will be made. And again, these are just like the circuit boards you guys will be soldering today. These can get manufactured very inexpensively, and it's a great way to kind of make a more permanent version of your circuit. And this even lets you change your the color you want. So if you want like a purple board, you can get a purple board. You know, if you want a yellow board, ooh, that's very bright yellow, kind of crazy. So you can even change the color. So at this point, what you're going to do for your documentation is you're going to want to take a screenshot of your schematic view. Okay. You're going to want to take a screenshot of your PCB design view, and then you're going to want to take one last screenshot of your 3D board, so you can kind of pose it in a really cool angle and take a picture of that for your documentation. And finally, just to kind of show you guys how inexpensive some of these can be, is we can go and actually see what these would be like to get fabricated. If we click on this G here, it's going to ask us if we want to do that design rules check again, and we've already done that. And so we can see that we can get 10 of these circuit boards made for just $5, which is pretty cool. And with this service that we use, if you design something that people really love and you need a lot of them, you can design up to 1,000 of them. And so really, really powerful design tool that allows you to make these circuit boards really quickly, very inexpensively, and they come in about 3 to 7 days. And so in terms of rapid prototyping, this is a really great tool to have under your belt, and we use it quite a lot in Creative Technologies. So once you have that, remember to take your screenshots and upload them as part of your documentation, and that's it.